Today, I'm really delighted to have the Best Paper Award-winning paper from ACL this year. Here, Beyond Accuracy, Behavioral Testing of NLP Models with CheckList. So I think this is a really exciting paper that really makes us think about the ways in which we evaluate our models. This it meant a lot to me personally. So in this paper, they looked at a lot of existing, widely used NLP models and APIs which are out there, and found some ways which may be a little bit embarrassing in which the accuracy was maybe not as robust as what a simple held out test set data would have us to believe. So this included a product that I was previously responsible for. So I ran product for Amazon Comprehend, AWS's first NLP service. So I launched that. And I think they evaluated on a later version of the product since when I was there, but I'm quite sure that all the errors that they found in their paper were true of the product when I was the person most responsible for not having those errors. While it was a very humbling experience to read their paper, I thought it was a really valuable one for me personally. Obviously, we want to see our models be as robust as possible. And a lot of us who come from industry know that we need more than held out test data sets. And we always have kind of a bunch of held aside gotcha test data sets and known problem items. But what I didn't have personally, and what I know a lot of people didn't have, is a more systematic way of trying to keep track of the ways in which we should be looking for accuracy and bias and fairness and robustness in our models. So I'm very excited that we'll have Marco Tulio Ribeiro presenting the paper here today. And two of his three co-authors are also joining us. Tongshuang and Samir here. All three of those will be able to answer your questions in the chat while the presentation is going. So please do ask your questions there or just drop by to say hello. And then following the presentation, so in about 30 minutes time, the three of those will be able to take your questions live. So again, I'll be asking you to ask the questions in the chat right then. And then if you're comfortable, I'll call on you to come ask those questions live on the Zoom meeting. So thanks once again to our presenters, and thank you to everyone who's coming to watch or to participate today. Before we get started, I'd like to thank Marco, Tongshuang, and Samir for joining us here.
Thanks. Those are very kind words. And this is a recording, but I just wanted to introduce in the recording. I didn't introduce us. So I'm Marco. I work at Microsoft Research. I did my PhD at UW with Carlos as an advisor and Samir as an advisor as well. Samir was a postdoc at the time. He's now a professor at UCI. And Tongshuang is also a student there that I collaborate quite a bit with. So I apologize in advance. I don't have a fancy microphone like Robert where the quality is super high, the quality of my microphone. This is a regular headphone, so it's not as good. But yeah, I'll be around to answer questions throughout on chat and later on. Thanks.
All right, thanks, Marco. You're coming through loud and clear for me. So I think whatever microphone you're using is working just fine. Okay, well, with that, we'll start the presentation. Please come join us in the chat.
Oh, we can't hear it. I think you have to share your sound. This is the problem we're trying to address in this paper. Very simply, how do I check if my model works? I have a model, how do I know if it works? So let's say that I'm a researcher or some data scientist or engineer, and I train a model, deep neural network, and let's say that it's great. I can even write a paper and say, look at this benchmarks, it beats all of the previous results on this benchmark, it's really good. How do I know if it actually works? How do I know if I can go ahead and replace my doctor with, let's call this model Oscar, with this model because it achieves good results? Or if I'm at a company, which I am obviously at Microsoft, should I go ahead and use Oscar in our products? Or if I'm a PM, should I go ahead and say, let's replace whatever we have with Oscar because of good benchmark results?
And you may be thinking, well, just check accuracy and you will know, like look at cross-validation, look at test sets. But there's many problems with accuracy. Anyone who has trained any model and tried to apply it in the real world knows that there are shortcuts that models can exploit that inflate accuracy, but when you try it in the real world, it actually doesn't work as well. There's all sorts of behaviors. The model may be biased in particular ways that put you in the news for all of the wrong reasons. So the problem remains, how do you check if it actually works? One approach that people in academia, including myself, have taken is to write more papers. So you have a paper on a model that's super good, and then you write a follow-up paper or other papers where you say, this is when it works, this is when it doesn't work, this is when these are particular problems that it has, and so on. So you do in-depth analysis. And that's great. I've written some of those papers myself, but it's a lot of work. It doesn't scale. Like, there's no way that every engineer or every team even is going to be doing this kind of in-depth analysis for every model. So what we're proposing in this paper is something simpler. It's not a replacement for writing papers, but it's something that is achievable for anyone, which is to test NLP models just like we test software. We've been writing software for a while. We have a set of guidelines as to how to test it, to make sure that it works or to make sure it doesn't behave in egregious ways. Let's apply those insights to NLP models. And that's basically what we did in this paper. So we're going to be taking some insights from software engineering and applying them to NLP. I have a color scheme there. Software engineering is orange, NLP is blue. And this is just a few insights. There's more that I'm not going to have time to mention. So here's a principle from software engineering that I think is really good and everyone should be familiar with. Test small units. You don't just test your system as a whole. Typically, you test individual functions. Now, of course, in NLP, what you get is one model. You can't just go and test individual components of it. But what you can do is test specific capabilities. So this is providing guidance as to what to test. We're telling users, hey, consider testing these things. And here are some linguistic capabilities. We have a list of 10 that are the least that people should be testing. So testing the model vocabulary, testing named entities, testing negation. So we have a list that's pretty generic as to what to test. Another principle from software engineering, there's a particular branch of software engineering testing that's called behavioral testing. And it's saying, look, let's decouple the test from the implementation. Sometimes you even have separate teams testing software so that you don't tailor the test to the implementation. And if you think about it, this is the opposite of what we do in NLP or machine learning in general. We typically collect a data set and then we split it into training and test. So clearly there's a clear connection between the data you trained and the evaluation you have. So clearly the way we apply this is to decouple tests from training. And the way we do this is we're going to test the behavior of the model. Rather than just testing how well does it do on specific instances, we're going to test for specific behaviors with different test types. And in particular, we have 3 test types that we're going to be proposing. And this makes a matrix where the rows are capabilities and the columns are test types. So you get a matrix at the end. First type of test type is similar to a unit test. So in unit tests, you have known inputs and outputs. And we're calling this a minimum functionality test. You also have known inputs and outputs. So you can think of this as a unit test for an NLP model. But notice that it's a unit test for a specific capability. So let's take sentiment analysis, for example. If I was testing a sentiment analysis model, what would be a good minimum functionality test for vocabulary? It would be a set of examples like this. This was a great flight. I hate this airline. I like the seat. So this is the minimum. If you're training a sentiment analysis model, it should work on simple examples like these. This is testing vocabulary. And maybe you get 500 of those or something. And then you can get an error rate and see how well does my model do on the simple examples. But if we're testing negation, the inputs and outputs would be different. Basically, you would have things of negation. This cabin crew was not good. The pilot wasn't nice, and so on. So you can get very targeted tests where you're testing specific capabilities. The types of tests are based on this field in software engineering called metamorphic testing. And the idea is simple. You take existing inputs and you apply perturbations to them where you know what they expected, either the expected output or properties of the expected output. So here's an example that we call invariance tests. You apply a perturbation where you know that the output should not change. You don't need to know what the label is, you just need to know what happens when you apply perturbation. So here's an example for the named entities capability. If we have tweets and we want to get their sentiments and we change location names, like we change Chicago to Dallas, we change Brazil to Turkey, no matter what the model predicted before, the prediction should not change if you change a location name, because we know that location names don't carry sentiment. So this is an invariance test, and it's inspired by these metamorphic tests. And the last type of test is what we call a directional expectation test. And it's the same thing, but rather than expecting invariance, you expect something else. So here's an example for vocabulary. Let's say that I have a set of tweets, and I add to the end of them very negative sentences, like, you are lame, I hate you, I dread you. I don't know what the label should be, but I know that sentiment should not become more positive. Whatever tweet you have, if I add I hate you to the end, it should not become more positive. It can stay the same or go down, but it cannot become more positive. This is an example of a directional expectation test. So CheckList is just a simple process where you're filling this matrix. This matrix guides you. What do I test? How do I test? And you come up with these tests. And in the end, you get a matrix and you can apply it to your model. And you get pass or fail. Or you get failure rates, like failed 150%, 80%, and so on. So it's a very helpful process in order to think about how to test these models. Now, I did say that sometimes you need to come up with 500 examples, and that seems like a lot of work. So we provide a lot of tooling that help people write tests at scale. So one kind of tooling we have is templating. So once you write an example, like I like this movie or something, you should be able to generalize that to other examples like I love this movie, I enjoyed this movie, or I like this book, and so on. So the way we do this is we have these templates and we give you suggestions so you don't have to think about it. So for example, this is a blah movie. It suggests good, excellent, interesting, and then the user just selects which ones make sense. So in this case, we say, whatever is positive, I accept. Whatever is not positive, I don't accept. And this makes it much easier to write tests at scale. And we have visualizations and whatnot. We also have a bunch of lexicons. So for example, we have common names, and we have these in like 100 languages, location names, and we have all sorts of lexicons that make it easy to write this unit test and also the perturbation tests. We also have a perturbation library. So there are certain perturbations that you always want to try, like adding typos, what happens, changing names, changing location names, and stuff like that. So we have a library that makes it easy for people to just apply those perturbations. And it also makes it easy to come up with new perturbations. We have visualizations. In some, we have a lot of tooling so that this is not a burdensome process. You could checklist, or you could, we use it as a verb, you could checklist a model in a couple of hours easily. And we also have visualizations, like if you want to see the results of your test as a matrix, we have this visualization where you can see each individual test, different failure rates, and then you can click on one and see the examples that are failing and so on. So in sum, we have a lot of tooling. Now you may be thinking, well, this is too simple. Like there's no way that I find any bugs on those that are, well, let's test some state-of-the-art models. And we did test 3 different domains. First one is sentiment analysis. So here we tested sentiment analysis for Twitter. And the reason we picked Twitter was that we're testing many commercial models. Google, Amazon, and Microsoft are our own cognitive services. And all of them use Twitter as a use case. So they should work for Twitter sentiment analysis. We also tested some research models, not trained on tweets, trained on movie reviews, but just to see how they did on our tests. And I'm just going to show you a few examples of tests and failures. There's many more in the paper and even more in the open source release. So here's our matrix. I didn't tell you about all the capabilities, but this is just to place us on where we're at for a specific test. So here's a test for the vocabulary capability and invariance test. And what we're doing is we're replacing neutral words with other neutral words. So for example, if you have the nightmare continues, we change that to our nightmare continues. And this is automatic. It's not that we had to do it by hand. We do it with Roberta. It says Bert, but it's Roberta. And then we measure how often does the prediction change when we change this stuff that does not change anything. And here are the failure rates. And you can see that they're pretty high for some of the commercial models. So 16.2% of the time, Google's predictions change when you change this kind of stuff. It's also high for the Microsoft model and for research models. So this is an example of an invariance test. I showed you this adding negative phrases test before, just adding I hate you, I abhor you, and so on. And you can see that Google, like 35% of the time, almost, sentiment goes up after you add a sentence like that to the end of a review, or to the end of a tweet. And it goes up by a margin, and we set that margin to 10%. So it's not just, oh, it went up by a little amount, it went up by at least 10%. Here's some robustness tests. Like if you're doing Twitter, you would expect that adding random URLs or @ signs would not change anything. So all we're doing is adding a random thing, and this is not adversary, it's random, and seeing how often do predictions change. And it's quite high, even for commercial models. You see like 25% of predictions from Amazon change if you add a random URL. And that's concerning. That's something that we should be testing for and fixing. In terms of temporal awareness, this is a little more complicated, but we're doing a temporal change. So I used to hate this, now I like it, or I used to like it, now I hate it, and so on. And see if the models can understand that temporal change. And failure rates are about 40% for all commercial models. Research models are a little better. We did very simple negations. So this wasn't a lousy customer service, should not be negative, should be either positive or neutral. Failure rate is very high, I think, 54% for Google. If you're putting out a sentiment analysis model, and it's the same for Microsoft and Amazon, it should work on simple negations like this. So this is something that we should be testing for. And if you do negation a little more complicated, like if you end with negation, I thought this would be awful, but it wasn't, then the failure rate is 100% or 90% for Google. Super high for all models except for one of the research models. We also did very simple stuff like things in question and answer form. Do I think this is bad? No. Do I like this? No, and so on. And again, failure rate is almost 100%. So it's clear that there's a lot to improve in these models, and there's a lot of, I consider these bugs that people should be fixing in sentiment analysis. Here's a different task, Quora question pair. This is a task where you have two questions and you want to predict if they're duplicates, because if they are duplicates, you want to send them to the same link. So this is a standard data set for NLP. And research models are supposed to be better than humans. So their accuracy on cross-validation is superhuman, like it's, I think, 1.2 times what humans have. So we wrote some tests. Very simple vocabulary test is, or part of speech test is, if you add a modifier, is this person a teacher? Is this person an accredited teacher? And clearly those are not duplicate questions. And failure rates here for examples like these, whenever I show one example, you should generalize in your mind to different templates. Here's 1,000 examples. So failure rate is 78%. So no human would make this mistake, but these models do. Here's a directional expectation test for named entities, where we're changing the name in one of the questions. So if you have two questions about the same entity, in this case Donald Trump, in one of them, we change it to a completely different entity and expect the prediction to not be duplicate anymore. And failure rate is about 1/3, which is pretty high. Another example from NER is we keep the entities, but we fill in. So we generate questions that are very different. Will it be difficult to get a US visa if Donald Trump gets elected? Becomes, will the US accept Donald Trump? And these are clearly very different, but they have the same entities. And we're expecting prediction to be non-duplicate. And there are duplicates about 1/3 of the time. So clearly there's some shortcutting going on here, where the model is saying if there's the same entities, often they will just predict duplicate. Temporal awareness, very simple, is before and after different things. Like, is it unhealthy to eat before or after 10 p.m.? Those should not be predicted as duplicates, but Bird predicts it as duplicates 98% of the time, and Roberta 1/3 of the time. Simple semantic role labeling, like active and passive. Does this person love this other person? Is this other person loved by this person? So it's the same thing. Failure rate is 2/3 and almost 100%. And then if you change the semantics, like does Anna love Benjamin? Is Anna loved by Benjamin? Those are different. Can the model figure it out? No. So it basically, this model cannot figure out agents versus subjects versus objects and so on. Failure rate is 100%. So clearly not superhuman in terms of ability, even though cross-validation would seem to indicate that. And then finally, we did SQUAD, which is question answering, and we tested one model, BERT, which is also supposed to be superhuman performance. And this is where you get a paragraph and a question, and you have to answer a question about it. So here's some tests for taxonomy. We did basic properties, like There's a large pink bed. What size is the bed? And we expect the model to know that size refers to large, but it predicts pink. And it does so in 82% of examples like these. For simple antonyms like pessimistic, optimistic, or opposites, and so on, failure rate is 100%. It doesn't do well on the antonyms we tried. In terms of temporal awareness, again, we did before and after, last and first. So, for example, Logan became a farmer before Danielle did. Who became a farmer last? Failure rate is 83%. And any human basically would not make mistakes like these. We did very simple negation, both in the context and in the question. So the simplest things you could think of, these are minimum functionality tests. Aaron is not a writer, Rebecca is. Who is a writer? And you expect it to be Rebecca, but Bert thinks it's Aaron 2/3 of the time in examples like this. And when the negation is in the question, it gets it wrong all the time. If you have two people, A is an editor, B is an actor, who is not an actor, it cannot figure this very simple behavior out. We did simple fairness tests. I can't get into the details, but there seem to be some selective mistakes going on here. So if you have male name is not a doctor, female name is who is a doctor, it thinks that the man is a doctor 93% of the time, but if you change it around, it doesn't make the mistake anymore. So it doesn't make the mistake when the woman is a doctor, but it does when the man is a doctor. And it flips when you do secretary. So it's saying women can't be doctors, man can't be secretaries. So there's some bias going on that you want to test. We also did very simple co-reference, crucial for question answering. So just having two people, you just have to resolve the co-reference, figure out who the he refers to, who the she refers to, or who the former and latter refers to, and it fails 100% for all examples like these. So it basically cannot do a very simple co-reference. And again, this model is supposed to be better than humans. And finally, again, agent-object distinctions. The simplest thing you can think of, Christian punched Nicole. Who was punched? Question answering system should be able to get this right, but BERT does not. There's many more examples. This is just a sampling. And the point I want to get to here is that we use the same process. We use the same matrix. We use the same kinds of tests, and we detected bugs in completely different tasks and models. Commercial models, research models, and we have tested more since then and have found similar results. The process is really helpful for coming up with this stuff. And it's also the case that state-of-the-art models still display many bugs. Like these are bugs that are there, and we should be able to fix them, especially in commercial models. You would think that we would have known about this, but many of these bugs were unknown to the community, I think, to the research community and also to the commercial community. So this is helpful. Like this tool can really help. But a question you may be asking is, how hard is it to find these bugs? Is it the case that you guys are just good at finding bugs and no one else applying this process is going to be able to do it? And the answer is no. And we have two different experiments to kind of show that. The first is a case study. So I went to the team at Microsoft that trained the sentiment analysis model that I just showed, that had a few bugs and so on. Same with Google and Amazon, but I had access to Microsoft's team. And I asked them, hey, how do you guys test this stuff? And they have a very good system. Like the model was stress tested. It's been in production for a while. It has customers. They have all of these benchmarks to make sure that models are working. And still, all of these bugs got through. So I asked them, hey, are you guys willing to do a session where you guys try to checklist your own model? So I didn't tell them the bugs that I found. I just gave them the process. And they came up with a bunch of tests. And we did a 5-hour session where I was helping them code whatever tests they had. And they found many new bugs. They tested new capabilities that they hadn't thought about testing. And even stuff that they had thought about testing, like negation. Of course, you're going to test negation sentiment analysis. They tested it way better. And this is what they said. And more interestingly, they found the same bugs we found, and they found new bugs. So this is something that can be helpful even for models that are already stress tested. The process really is helpful. We also did a user study where people, and the case study was with people who are experts. These are people who are training the model. The user study was with researchers or software engineers who are not working on the domain. So we did KQP, and the subjects did not have experience with KQP. And they're testing a model that they didn't train. They're testing BERT. But we wanted to see, do they find the same bugs in the state-of-the-art model that we find? And here we only gave them 2 hours instead of 5 hours because I wasn't helping each person individually. So we have 3 conditions. Unaided, where we just told them, hey, here's a model, test it however you like for 2 hours. Here's a Jupyter notebook, create whatever test you like. We have a condition where we told them what to test. So we gave them the matrix, but we didn't give them any tooling. And then we had a condition where we gave them tooling, like templates and so on. So the 2 on the right are subsets of checklists. And here's what we measured. So in the 2 hours, how many tests did they come up with? And this is a rough measure because, of course, tests vary in their quality, but it is the case that with checklists, people came up with twice as many tests as without checklists in the same amount of time. We also measured how many test cases they had per test. And if you don't have tooling, it's very hard to, by hand, come up with a bunch of different test cases. So with no tooling, people typically did 5 to 7 test cases. With tooling, they did 200. So you just have tests that cover way more of the space that you're trying to test. And then finally, we measured how many bugs they found in the model. And this is somewhat subjective. This is self-reported. We asked them to measure bugs in severity, in a severity scale and so on. And we also had someone else evaluate all of the bugs that people found, someone who did not come up with them and got the same results. So while it's subjective, it's a measure that people are finding more bugs, more severe bugs with checklists than without. In this case, almost 3 times as many severe bugs. So checklist is just better across the board than just doing it on your own. Even testing on your own is already a win if you compare to current practice where people just do cross-validation, but using checklists, it does seem to help quite a bit. And the users found the same bugs we found. So the bugs that I presented before, it wasn't that we were very creative. It's just bugs that are there to be found, and people in this user study found them. And they also found new ones that we hadn't found, obviously. So here's a summary. If you take one thing away from this talk, it's this. We should test NLP models beyond just accuracy. Accuracy is great. I'm not saying we should replace accuracy, but we should do more. And we're suggesting let's borrow insights from software engineering. Like testing for software engineering really helps increase the quality of the software that we put out. It's not a silver bullet. It doesn't solve evaluation, but it helps quite a bit. And in this paper, we basically have the full package. We have a guide. This is what you test. This is how you test with simple examples of perturbations. We have tooling with fill-ins, visualizations, lexicons. So it's a complete package that I think should be really helpful for anyone doing NLP. And you can try it out. It's open source. I'm maintaining the open source project, and we already have people using it, giving feedback, and I've heard that it's been really helpful for other people as well. And you should also check out the paper because there's many examples that I didn't list. Of course, in a quick talk, I can't go over everything, but the paper has even more fun examples. And actually, that's all I got. So I'm ready to take any questions about any of this or anything else. Thanks.
All right, thank you, Marco. So that was a fascinating talk. I'm really excited to try and use some of these techniques myself. And hopefully some other people feel some internal embarrassment that, like me, they hadn't been so comprehensive in evaluating their models in the past. So Marco, Tongshuang, and Samir are here live to take your questions. So if you'd like to ask your questions in the chat, then I'll invite you to turn on your video or unmute and ask those questions live. If you'd like to ask a question but you're not comfortable asking it live, just let me know in the chat and I can ask it on your behalf. While you're asking your questions there, I'll ask one to kick it off. So Marco, Tongshuang, and Samir, have you run this past any field linguists? So as someone who has gone and studied languages to try and document them for the first time, a lot of what we look at is different linguistic paradigms. So does this same sentence mean the same thing when we alternate just one word? Does it mean the same in different like sentences, like active versus passive? Does it mean the same thing in different social settings? And so it feels like there's a lot of similarities in applying the discipline and trying to fill out this grid of variation and to understanding when meaning should and should not change.
Gotten some feedback from some linguists at ACL and different talks that I gave in different places. Obviously, we read a bunch of papers by linguists and tried to glean whatever we could when we were coming up with this hierarchy, these capabilities. We're borrowing from a lot of that, but none of us are linguists. It's not like we consulted a linguist in order to come up with categories from linguistics. We did come up with stuff that I think you don't have to be a linguist to understand and use, and I think that's really important for something like this. I don't know if Samir has something to add here. As a professor, he has way more contact with linguists than I do.
I guess one thing I would add is a lot of NLP applications tend to ignore the linguistics part of the problem, and rightly so in many cases because it might not be relevant. But CheckList is sort of showing why thinking about linguistic properties and linguistic changes and structures could be useful as a way to test what your model is doing and what your model cannot do. So a lot of our tests are inspired by stuff in linguistics, but maybe a lot of sentiment analysis people maybe haven't thought of semantic role labeling before. But this is one case where it would be useful for them to use this vocabulary.
Makes sense. And Tongshuang, I know you're at University of Washington, which has a really strong linguistics tradition. And in fact, we had a professor of linguistics and data science, Emily Bender, speak to us about their award-winning paper recently.
Yeah, I think Marco was also from UW and he was doing his PhD. So we kind of come from the same background, but I don't think we actively consulted people when we were developing this, but we definitely see a lot of papers, especially in NLI, where they try to construct challenge sets where they do this kind of linguistic reconstruction on the dependency tree, and I think that inspired some of the perturbation tests we were using.
Right. Oh, that's very interesting. Yeah, that was a great set of tests where I remember it was built as linguists versus algorithms, which was a little bit of hype, but the good kind of hype. All right. So it looks like we've got some questions coming in, and so Ralph, if you're there, we'd like to ask your question about solving the bugs. If you want to unmute and optionally turn your video on to ask that question, that'd be great.
Sorry, I admit I cannot turn my video on. I was just curious about how do you guys plan to since you have already recovered these bugs. I'm curious, how do you attack these bugs? Are you taking them or solving them independently? Are you rebuilding the entire model from the ground up? What's your proposal in terms once these bugs are identified?
Yeah, that's a question that we always get, and I'll also address the next one, which I guess is the same question, but with a little bit of follow-up. The next question asks if you can augment the training data with the same data that we're using to test. And we always get those two questions. I should actually add them to the talk. And the answer is that it's very hard to solve these bugs, and in particular, it's hard to come up with a general purpose way of fixing the bugs. And you can think about specific things. Like, for example, I showed a bug where if you have a sentiment analysis model for Twitter, you should have some logic in there that deals with hashtags and @ and URLs and stuff. That's easy to fix. You can do post-processing and stuff. But if your model cannot handle negation in the long range, or something that ends with negation, that's harder to figure out how to fix. So sometimes the answer is to add more data, sometimes it's to remove some data, sometimes the answer is to use a different model architecture. The answer is almost never going to be add the test set to the training data, because we're using these as tests. These are not comprehensive. So if you just add it to the training data, you surely get a great testing score because you're teaching to the test basically, but you've lost your evaluating ability, and you probably have just plugged a hole and the underlying problem is still there. You could just do that. So I always say, don't just add tests to the training set. That would be violating the principle of separating training from testing, separating implementation from testing, and so on that we're trying to implement here. But we don't have a good answer for a general purpose way of fixing the bugs. It really depends. We have some ideas for some, but not one to rule them all.
Thanks for that answer. Yeah, good advice in general. Do not add your test data to your training data. That's just generally bad behavior, and will result in a permanent ban from Bay Area NLP. So Jali Song, I hope that answers your question as well on augmentation. I think both were addressed there. Oh, it looks like it was great. So Yung Yao, it looks like you have a question about improving the models from an application point of view, which sounds like a little bit of an extension to the previous question. Are you there to ask about that?
Can I just add one more thing that I forgot to say? I forgot to say something in answer to the last one. A lot of times we're not even aware that these bugs are there. So finding them is the first step towards fixing them. So it's not like I'm saying you can find the bugs and then throw your hands up in there and say, I don't know how to fix them. Often just finding them is enough to point you towards a direction. It gives you insight. You can go and investigate whether it's a training set, whether it's a model, and so on. So just an add-on to my answer there.
I appreciate that. And it looks like Yao is having audio problems. So I'll ask the question. So it was, how can you test from an end user's point of view? So obviously this is great from the point of view of a product manager or someone leading the data science initiatives who want to evaluate their model. Is there a way that this could also apply to testing the experience of the end user of an application?
Yeah, so we have, when you say types of tests, we have the 3 test types that I think you can fit almost anything in there, but I think you're probably referring to the capabilities, or you're saying test negation, test NER, and so on. And those are not meant to be an exhaustive set. Those are meant to be an initial set of suggestions. Obviously, for every application, especially if you're doing something that's a product, you would have to add product specific, like the scenarios that you think would come up when people are using your product, as capabilities to test. And we explicitly say that users should come up with their own capabilities. So if there's a particular pattern of end user behavior that you think is likely or even possible to happen, you definitely want to add tests to that effect. That answers the question.
All right. And Kaveri, you have a question which is a follow-up to Ralph's about catastrophic forgetting. Are you there to ask that?
Yeah. Yeah. So basically, when you do discover a bug in a model, generally, if we try to add some new data, what the model does is that it forgets the task that it has previously learned, or the samples that it has previously learned. Something that we call catastrophic forgetting. In that case, we need to either retrain the model from scratch. So have you ever encountered this in the process of solving these bugs? And what do you do when the model starts forgetting these previous samples when you try to make it learn these new samples?
We think that testing is not something, like I don't envision people testing their models and then just doing a bit of fine tuning on top to fix problems. So I would not be surprised if after a round of checklists, especially if a model has not been tested extensively before, you would want to train from scratch most likely if you found very significant bugs. If you have only small stuff that can be fixed with post-processing, or if it's just a matter of adding some vocabulary, then sure you could do some fine tuning. But in my experience, when people have, at least people have told me that they've used it and what I've observed, you typically want to do something more significant than that so that you wouldn't be concerned about this kind of forgetting. But yeah, this whole paradigm, and Samir will probably have a lot to say here as well, but this whole paradigm of just fine tuning a little bit to try to fix problems is not something that I think is a good solution overall to guide models into specific behaviors.
Yeah. One analogy I like to make sometimes is if you write a unit test for any other software package, and if that unit test fails, the right way to fix that test is not to write a if condition in your code that matches the unit test and then do something different, right? That would be the wrong thing to do. And so somehow fine-tuning based on individual tests to me sounds a lot like that.
That's a good analogy. All right. So changing gears a little bit, Setu, you have a question about generative models.
Yeah, thanks, Marco, and all of the other authors of the paper. It's a great paper, and I enjoyed your talk, including at ACL. One question I had that is specific to this task was all of these tests appear to be very useful for NLU tasks. But what about generative models, and how do we adapt similar tasks for something like a summarization model?
Right. And we're also getting some questions about GPT-3, which I think fit well here. If you have a model that's generating text there. So I think that it's a little more challenging to write the task when you have generation, but it's perhaps even more valuable because the metrics we have are not as trustworthy. So if all you're doing is measuring blue, you really trust that that's doing something reasonable. So what ends up happening is as you're writing tests for tasks like generation or something, you end up testing more of the properties of the output rather than saying, I expect this particular output. So that the perturbation tests become more relevant, but even if you're doing minimum functionality tests, you end up testing things like, for example, if you're doing translation, rather than, let's say you're doing summarization. You're doing summarization, and you know that there are specific words that have to show up in the summary. It's hard to say this is what the summary should be, but if I'm writing an article about a company and the company's name does not show up in the summary, that's a bug. So you end up writing properties like that. So look at the output. Does this name appear? Does it appear in this order? Does it include this particular verb or verbs that are similar to this one that have to show up in the summary or stuff like that? And I think that, again, it's a little more challenging because you can't just say positive, negative, and so on, duplicate, non-duplicate. But I think it's more valuable because you may end up with high blue score and not even mention crucial stuff in a summary or in a translation or something like that. And I guess I touched on GPT-3. I started testing a bit of generation. This is not in the paper. We did some GPT-2 generation. I've tried to get access to GPT-3, but it's the release is gradual, and I wasn't able to get access so I could test different capabilities in GPT-3 yet. But I'm still hopeful that at some point I'll get access and then I'll get some answers to see how it's doing. It would be really cool to test a lot of the stuff that I've been seeing on Twitter and stuff that GPT is doing. I'll be happy to test that. Just haven't been able to get access to the model yet.
Yeah, they've made the API paid now, so it's open to anybody who wants to.
Oh yeah, so I should go pay for it.
Yeah.
Get Microsoft to give me some dollars so I could go test it.
Nice. I think that answers the questions by Tom and Tao as well, who are both interested in generation and summarization. Zhang, you have an interesting question about whether this should become a standard. Are you there to ask that?
Sure, I can ask. I really like this paper because it goes on top of the current evaluation metrics that we use. But from the way it presented, it is more for the industry side. And personally, I've been working with semantic role labeling, and I can see that changing the nouns into some other, like maybe some other name entities could be really helpful for testing the models. But from what I know, it's not the current standard practice yet among the research. Also, I'm just wondering whether Marco is saying that this paper could be actually adopted by the current research industry, because I believe there's a lot of metrics right now. They are being used is pretty much biased. It's not like evaluating the model precisely or well enough such that we can have a superhuman performance that performs so badly when it comes to checklist.
Yeah, I guess there's two things. One is checklist is a process and a tool that I think if it sounded like I'm focusing more on industry, it's just because it's the audience that I kind of expected here. But I think researchers should be doing this process as well of testing their models. I think it gives great insight and helps people compare between models and stuff. So I think that this is valuable for research and for industry. It's just that the benefit in industry is more immediate. For example, if you don't end up in the news, that's a good thing. End up in the news for a bad thing. I mean, as far as this becoming like standard metrics or benchmarks, so there's, as a process and a tool, what you end up in the end is with a suite of tests, right? And I am not confident that you should take my sentiment suite and say, this is now the standard for sentiment analysis. But I do think that it's helpful. I do think that if I was writing a sentiment analysis paper, I would run that model through my suite to see what it's getting, what it's not getting compared to other models. What I envision, and I don't know if this is going to happen, but what would be great is if the community collectively came up with a set of tests so that rather than a top-down thing of saying you have to use this checklist, just that the community would converge on a set of suites or a set of tests that say, okay, if we're releasing a TQP model, it has to pass this, like, or if we're doing sentiment analysis, it has to behave at least in this ways. So I'll be very happy if people in research were doing this. And I try to make it very easy to create and to share these tests exactly so that people could do it. But it's very easy. Like if someone wants to reproduce my tests, it's a 2-liner on my GitHub repo.
All right, 2 lines. That sounds pretty easy. No excuses not to not to make that change if you want it. Just had a question come up here from Tom. Are you there to ask that live?
Yeah, working on it. Almost. Hello.
Hello.
So as I was listening to the conversation, I started thinking about the old Turing test from Alan Turing. I'm wondering if you see a relationship between the work that you're doing and the original idea of the Turing test, and if so, what do you see as the relationship, and does that show us any idea about how we might move forward with AI in general and language processing in particular?
I think Samir, looks like he wants to answer. I can answer it. If you don't
Go for it.
You look like you have things. Okay.
No.
I think the Turing test, it's very related because it's a behavioral test, right? It's saying, look, if you can exhibit this behavior such that you can fool a person, then you've done something useful. And this is similar. Instead of testing specific things inside the model, we're saying, look, it has to behave in this certain ways. We're not making, but I think this is less ambitious. I'm not trying to make any claims about AI or general artificial intelligence. I'm just saying, look, if you have a model, you have certain expectations, you should check those. You should write tests to make sure that it passes those. And obviously, if you have general artificial intelligence, it should be able to pass those tests. But clearly, being able to pass them is not saying anything about whether models are really intelligent or not. It's just saying that they behave according to what we expect in this particular behavior. And just like with software engineering, passing all of your unit tests doesn't mean that it actually works. It just means that it doesn't fail egregiously in what you have.
In known ways.
Yes.
Yeah, I mean, I think to Marco's earlier point, you don't end up in the news, and it's not a headline that your model does everything good. It's it's only the egregious errors that get you on the front page of the news. So Zhang, you had another question. This one's close to my heart about low resource settings. If you're there to ask that one.
Sure. I think so I was thinking about, since checklist basically propose certain ways to augment the data and use it for testing how the current models are performing. And then in the aforementioned discussion, you mentioned that we should include the test rules from checklist into the training data set because we want to separate the unit tests from the training data and stuff. I was just wondering, what do you think about using checklist to augment the data for the low resource NLP, because they are really suffering from the data problem? And it seems like what checklist has been doing is proposing some really good ways like negation and stuff to increase the size of the training
Yeah, I don't know. I wouldn't use it to increase training data. We are working on some multilingual stuff to test even low resource settings, but mainly for testing. Because again, if you think about it, we're doing templates, so the data you end up with is very focused. It's very directed, and it's very easy for a model, if you add that to the training data, to just kind of learn the template rather than the behavior itself. So if you add 1,000 examples from the same template to the training set, it's not as if you're adding 1,000 examples you collected generally. It's more like you're adding one big example, and if you have a flexible model, it's just going to learn to pick up on that particular pattern. So again, just to emphasize, I don't think we should be using this for training, but rather for testing.
I guess another caveat I would add to that is the tools that CheckList is using, even though we are trying to make it multilingual and stuff, a lot of them work for high resource languages. So like BERT for English is going to be much better than BERT for other languages, especially when you think about low resource stuff. So even NER and all of these tools that we take for granted just don't apply. So those will be some caveats that will have to accompany CheckList for other languages.
Right. It is multilingual right now, but as Samir has mentioned, it works much better in some languages than others. If you do, I can check Portuguese because I speak Portuguese. It works fine, but worse in English for sure. The kinds of suggestions you get for template fill-ins and stuff.
So do you ever have a follow-up question to that myself? When you look in other languages, do you find that the morphosyntax makes things a little bit more difficult? Because obviously in English, almost all of our strategies for negation are adding separate words. But in a lot of other languages, the main strategy would be adding prefixes and suffixes. And that just seems a little bit more complicated than replacing individual tokens.
Yeah, template writing is a little harder when you have gendered nouns, for example, because you have to make sure that you're using the right articles and stuff. So it is a little more challenging. I can only comment on Portuguese. I don't speak any other languages. But you can still write, like I've tried playing around with Portuguese, and even though it's a little more challenging for some stuff, there's other stuff that's easier. Every language is, in a sense, a bit of a snowflake in that, but there's general patterns that apply. Like there's still names in Portuguese, there's still negation, there's still a bunch of the same stuff. So I think CheckList is still pretty useful, but it's to be decided how much all of this generalizes, and that's somewhat that we're trying to explore and understand.
So that'll be the best paper next year at ACL then.
I don't know about that. No problem.
All right, we have time for one more question. So B.A. Rao, are you there to ask your question about adversarial?
Yeah. So I was just wondering that the test cases which you have devised, adding extra terms, I abhor this, or maybe shuffling some words. This seems very similar to adversarial attacks to models. Do you see that similarity, or if it is different, why? Can you explain that?
One immediate difference is that these is treating the model as a black box, and you're writing the test. You're not writing a test for a specific model. You're writing tests to be applied to any models. So typically adversarial attacks, you get access to model gradients so that you're trying to construct examples that fool that particular model. And to me, it's a little less concerning. It's still concerning if your model is susceptible to those. But it's a little less concerning than if you have examples in the wild that could appear in the wild and models don't know how to handle. But adversarial attacks would fall into robustness. Like if you want your model to exhibit robustness to small perturbations, I would write that as a test. I just prefer to think of these tests as general purpose rather than model specific, so that you can compare different models. But once you change your model, you don't want your examples to become obsolete. If that makes sense.
Yeah, makes sense. Thanks.
Okay, and we're at time, so apologies if we didn't get to your questions. It was really great chat during the talk and following. I'd like to thank the authors of this paper, Marco, Samir, and Tongshuang for joining us today. Thank you again.
For the invitation.
And congrats on the best paper award. I think it was well deserved.